Okay? All right, first one is multiplicative identity. Remember we talked a little bit the other day about the additive identity. I asked you, what would you add to yourself to get yourself back? Well, I know that sounds like a silly question. But it's what you multiply a matrix by to get itself back. It's called the multiplicative identity. So if I take matrix A, I multiply it by the identity, I will get back matrix A. Okay? There are two choices. There's the 2 by 2 identity. 2 rows, 2 columns. We've seen this one before. 1, 0, 0, 1. Okay. If you multiply a matrix by the 2 by 2 identity, you should get that original matrix back. Okay. For the multiplicative identity, the commutative property is true. If I take the identity times A, I will also get A back. The other one that they might throw at you guys is the 3 by 3 identity. Okey-doke. All right, next one, multiplicative inverse. If you take a matrix A, multiply it by its inverse, you have to get back the identity matrix. So what's that's saying is if you take A times its inverse, you will get back, for example, if it's a 2 by 2, if you take a matrix times its inverse, you have to get back 1, 0, 0, 1. So if I take a matrix, multiply it by its inverse, you have to get back 1, 0, 0, 1. If you don't get 1, 0, 0, 1, then these two are not called inverses of each other. And tomorrow we'll talk a little more about why we need to have inverses of each other. Okay? All right, so question is, how do you find the inverse of a matrix? Remember, the additive inverse is when you take a matrix, you add the opposite matrix, and you get 0, 0, 0, 0. Okay? How do you find the inverse of a 2 by 2 matrix? We're just going to talk right now about a 2 by 2. We will eventually hit on the 3 by 3s also. Okay? So, if matrix A equals A, B, C, D, how do we find the inverse?
Multiply it by 1, 0, 0.
That would give me back A, B, C, D. So that would be showing the identity. So if that was an
Multiply by its opposite.
yes. So we have to find its opposite, okay? Now, there's a couple steps. You're on the right track, Leah. There's a couple steps to finding the opposite of this matrix. First of all, you have to find something called the determinant. And the determinant is not majorly difficult to find. The determinant is going to be A times B minus, always minus, C times D. So first you have to find the determinant. So sometimes I like to call it just the DET if we want to abbreviate.
Wouldn't that be A times D minus C times
Yeah, do I have that backwards?
Yeah.
That would be nice if I had it the right way. So it's A times D minus B I'll just write it over. A times D minus B times C. Thank you.
C
A-
times B?
A times D minus C times B or B times C. You'll get the same thing. Okay? All right. The inverse matrix. That denotes inverse. It's A to the little negative 1. So this means inverse. It's a big matrix. And the reason it's a big matrix is because it's made up of fractions. It still has to be a 2 by 2 because we're going to multiply matrices together. So this one has to be a 2 by 2. Okay? Each fraction is over the DET. Okay? And then this is kind of funky. What happens is A and D switched positions in the matrix. D here, A here. B and C stay where they are, but they change signs. So right here will be the opposite of B. Right here would be the opposite of C. Now, all right, are the matrices inverses of each other? Let's put example 1. Matrix A. -1, 3, 2, -5. Matrix B is 5, 3, 2, 1. All right, 2 ways to determine if they're inverses of each other. We are going to do Leah's method first, okay? Leah said that I should be able to multiply them and get the identity 1001, okay? So I need to flip to the back real quick. So everybody got this down? Okay, so we're going to put letter A. Okay, should get 1001. Okay, all right, so let's multiply them. -1, 3, 2, -5 times 5, 3, 2, 1. So we're going to say yes, they're inverses of each other. Second method, letter B, is to find the inverse of matrix A. So it actually is find the inverse of matrix A. Find the inverse of matrix A, and it should equal matrix B. Okay? All right, so let's do our little practice on finding the inverse. -1, 3, 2, -5. So that's matrix A. First step is to find the determinant. Anybody know what we multiply together to get the determinant? So how do we find the determinant? Okay, raise please. All right, Miss Natalie, go.
-1 times -5.
-1 times -5, and then is it plus or minus always?
Plus.
Always minus, and then
2 times 3.
good. All right, so we have -1 times -5 is 5 minus 2 times 3 is 6. So we get -1. Any questions about that, guys? All right, so now we're going to write A inverse. And remember, A inverse is a big matrix because we have to make fractions. And the fractions all go over the DET. So over -1, over -1, over -1, over -1. Okay. Anybody know what number goes on the top in row 1, column 1? Natalie?
-5.
Very good. Natalie, what about in row 1, column 2?
Just 3.
Close.
Oh, sorry, -3.
-3, opposite of 3. All right, Natalie, row 2, column 1?
-2.
-2. And then row 2, column 2?
-1.
Very good. So, these two numbers flip around. These two numbers change signs. And then the last thing you do is write the matrix, the inverse matrix that you get. -5 divided by -1 is 5. -3 divided by -1 is 3. -2 divided by -1 is 2. And -1 divided by -1 is 1. And does that equal matrix B? Yes. So are they inverses? Yes. Okay.